Good day, students. In this video I will show how to solve some selected questions from chapter 12 progressions, 12.2 geometric progressions. A geometric progression is given as 4, 12, 36 and so on. If the sum of the first n terms of the progression is 13,120, find the value of n. Okay, so we need to find the value of n. So how to do that? It's given the sum of the first n progression. So Sn equals to 13120. We know that. And what's the formula for Sn? Before that, we see that the second term is bigger than the first term and so on. So we use the formula, the r is bigger than 1. So we use the formula a r to the power of n minus 1 r minus 1 equals to 13120. And what is our a? A is 4. What is our r? R is 12 over 4. Okay, maybe I'll put this in a bracket. Minus 1 over 12 over 4 minus 1 equals to 13120. Try to solve this. 4, 3 to the power of n minus 1 over 12 divided by 4 is 3, 3 minus 1 is 2, 4 divided by 2 is 2, then when you bring the 2 to your right, you get divide. So we get 13120 divided by 2, 13120 divided by 2, you get 6560. And this is 3 to the power of n minus 1. Sorry, the minus 1 is not the power, it's the number here. So 3 to the power of n is 6560 plus 1, you get 6561, 3 to the power of n. Okay, so let us take log on both sides. Take log base 10 on both sides. So you get Lg 3 to the power of n equals to Lg 6561, and as an index you can bring it into the front to get n Lg3 equals to Lg 6561, n equals to Lg 6561 over Lg3. This one you'll try to solve using a calculator. So log base 10 6561 divide by log base 10 3, and then you get the answer as 8. That will be the answer. So the first n terms of the progression, the sum of the first n term is 8 terms. That means you add 8 terms, the first 8 terms, you get this as the answer. Moving on to the next question. Given a geometric progression 8, 16, 32 and so on, find the least number of terms to be added starting from the first term to give a sum that exceeds 15,000. Okay, so they want to exceed 15,000. So I can just write the statement here in a mathematical expression. Sn is more than 15,000. That's the question is. So first we look at r. R is it's more than 1. Our progression is increasing, so it's more than 1. So I'll use the formula a r to the power of n minus 1 r minus 1 more than 15,000. A is 8, r is 16 divided by 8 is 2, 2 minus 1 more than 15,000. So 2 minus 1 is 1. You can just ignore that. 8, you bring it over here, it becomes divide. So you get 15,000 divided by 8. One 875. So 2 to the power of n more than 1875 plus 1 1876. Okay, you can use log to solve this since n is the index. So I'll say take log base 10 on both sides. So I get LG 2 to the power of n more than LG 1876. N can comes to the front since it's an index. So n LG2, let's bring it to my right. So I get LG 1876 over LG2 log base 2. Okay, how about the sign? Let us check whether LG2 is a positive or negative. Log 2. Log 2 is a positive number. Therefore, the sign will still follows. Okay, so we'll try to solve this using a calculator. Log 1876 divided by log 2, and the answer is n is more than 10.87. Okay, so to get a sum that exceeds 15,000, your n should be more than 10.87, but we know that our n, it should be a round number, it can't be a decimal or a fraction. So the the smallest n after 10.87 is 11. So you can just write there the sum, I follow the question, the least hope you can see, yeah, the least number of terms to be added that I'll take from the question that exceeds 15,000 is 11. Okay, moving on to the next question. The sum of the first n terms of a geometric progression is given by Sn. Okay, then you have the formula. Find the fifth term of the progression. So you can see here that we don't have the first term and the common ratio, but we just have a formula for the sum, and then they want you to find the fifth term. Okay, so how to do this, I'll show you. Okay, can you see the paper? Okay, yeah, good. So fifth term, so we have first term, second term, third, fourth and fifth, but we don't have the first term and so on. What we have is the formula for sum. So to find the fifth term, what I can do is, this is the question. Okay, this is the question. So what I can do is, I can use the formula for sum. I can find the sum of the first 5 terms, that it will be S5, and minus with the sum of the first 4 terms, that will be S4. Okay, so S5 minus S4 is we'll use this formula. Okay, we use this formula. So 12 bracket 1 minus 1 over 2 in bracket to the power of n, n is 5 for the first one, minus 12 bracket 1 minus 1 over 2 to the power of 4. Okay, we have to solve this. So this becomes 12 bracket 1 minus 1 to the power of 5 is 1, 2 to the power of 5 is 32, minus 12, 1 minus 1 to the power of 4 is 1, 2 to the power of 4 is 16. So get 12 minus, okay, this is a fraction. In terms of fraction, it becomes 32 minus 1 over 32 minus 12, 16 minus 1 over 16. So get 12, 31 over 32 minus 12, 15 over 16. Simplify somehow. Okay, so this will become, simplify in terms of 4 becomes 4. So 4 is I don't simplify. I can make it the same, the denominator same, so that I can minus easily. So what I'll do is I'll just multiply 12 and 31. So 12 and 31, when you multiply, you get 372 over 32 minus, okay, here it's I can just multiply 12 and 15, but the denominator is 16. I want to make it as 32, so that easy for me to minus. So I'll times 2 again. Okay, so 12 times 15 times 2 over 16 times 2. Why I'm doing this? Because I want to make the denominator same as 32. Okay, so 372 over 32 minus 12 times 15 times 2, I get 360 over 32. So 372 minus 360 is 12 over 32. Simplify, you get 3 over 8. That will be your fifth term. Okay, the next question, okay, I hope you can see. B, the sum of the terms that the 7th to the 10th term of the progression. The sum 7th to 10th. So we want you to find the sum from 7th to 10th. So I'll illustrate, it's easier. T1 and so on. Then you get T6, T7, followed by T8, 9 and T10. Okay. Now, the question asks you to find from 7th to 10th. This is the question. So as usual, you have to find everything first. 1 to 10, that will be S10. And then minus with S6. Okay. So I don't have enough paper, enough column here. I'll take another paper, do it another paper. Okay, there. I think this will help. So S10 minus S6, I can get the answer for the question. So we are doing the B. S10 minus S6. So follow the formula. For S10, the formula is, let's replace 1 minus 1 over 2 to the power of 10 minus 12, 1 minus 1 over 2 to the power of 6. Okay, so use the formula given in the question. So S10 is just replace the 10 and with 10, S6 is n with 6. Okay, try to solve this. 12, 1 minus, okay, 10 to the power of 2 to the power of 10, 2 to the power of 10, I get 1024. Okay, so I get 1024 minus 12, 1, 2 to the power of 6, 64. So 12 at 1024 minus 1 over 1024, okay, minus 12, 64 minus 1 over 64. Solve this. 12, 1023 over 1024 minus 12, 63 over 64. Okay, yes, I'll try to solve this. Let me see. Okay, I'll use the calculator to solve the fractions. So 1023 times 12 is okay, hold on. Answer I get 3069 over 256, and this one (189 over 16). So I'll just minus both fractions. So I get 45 over 256, and in terms of decimals, you can write this as 0.1758. So that's the answer for B. Okay, so that's all. See you again in the next video.